Hey guys, welcome to the LearnAP Calc second live stream here at LearnAP. Glad you guys could join us. If you have any questions, submit them now and I'll do my best to answer them. But seeing as that there's no questions, I'll just start with a basic problem here. Find the limit of square root of x minus 2 times, over 4x minus x squared. Okay, so evaluate this limit. As I talked about in the videos, we always do direct substitution first. So this is square root of 4 minus 2 over 4 times 4 minus 4 squared, and this of course is 0 over 0. So this is indeterminate. We have to do more work. Well, here I talked about several methods: factoring, conjugation, lowest common denominator. But this one is pretty obvious that we need to conjugate it. As I said in the video, when we have square root of something, that's a pretty good sign that we need to conjugate. So let's go ahead and do that. So as I said, when we conjugate something, we multiply by the first term plus the opposite of the second term. So here our second term is negative 2, so the opposite of that would just be 2. And then of course we're putting it over itself because this would essentially be multiplying by 1. So limit x goes to 4 of x minus 4 all over 4x minus x squared times the quantity square root x plus 2. Okay, so you might be curious how I'm getting this right here so easily. And this is something called the difference of two squares. I'll write this in a different color. Okay, so difference of two squares, also called dots. So if I have, say, x minus 3 and x plus 3, or essentially any term that's the same here and here, and then these terms are also the same but opposite. This is the difference of two squares, and I can always just multiply these terms here and forget about doing the rest. You're probably familiar with FOIL, which is basically distributing two things like this. But here all I have to do is multiply these two. And to see why, if I multiply x times 3 here, I get 3x, and here I get minus 3x, and this comes out to 0. So anytime we have difference of two squares, like so here, I just multiply the first terms and the second terms, and I can leave everything else out. So here I'm multiplying square root x, and here I'm multiplying 2 and negative 2, and that's how I'm getting x minus 4. So if that confused you, that's the explanation. Okay, so that being said, we have this new limit here from conjugation. So what do we do now? There's not really any terms that are obvious to cancel. well, now we can actually factor the bottom. So again, here top, x minus 4. I'll factor out an x from this term right here. So we get 4 minus x times the square root of x plus 2. And now these two are close to canceling, but they're opposites of each other. So let's multiply, or let's make the top term look like the bottom term. So the way I would do that is just simply write negative and then take the opposite of this. So 4 minus x. So if you're confused, if you distribute this negative here, I'll end up with x minus 4. So I'm just simply rewriting this term to cancel with the bottom. Okay, and now we have just rewriting the bottom again. We can see that these cancel. I'm left with limit as x goes to 4 of negative 1 over x times the quantity square root x plus 2. Alright, now we can do direct substitution. And here I get negative 1 over 4 times the square root of 4 plus 2. Which here, square root of 4 is 2, plus 2 is 4. 4 times 4 is 16, minus 1 over 16 is our limit. Alright, so if you had any questions on that, be sure to leave a comment, but otherwise, if you have questions on something else regarding AP Calculus, be sure to leave a comment. If there are no comments, however, I can move on to something else. How do you convert y equals 3 over x to polar? Okay, good question. Let me get some more space here. That's not what I wanted to do. Okay. So, the question was, question is, convert y equals 3 over x to polar. Okay, so anytime you're trying to convert to polar, to Cartesian, or back from Cartesian to polar, you need to know the polar master equations. And these are r squared equals y squared plus x squared. R equals cosine, should be x equals r cosine theta. Y equals r sine theta. And then tan theta equals y over x. This last one you won't use as much, but I don't know, it's useful to know. Okay, so the question here is simply which of these equations are we going to use? Which are sort of the most useful to us here? Well, here we just have y and x, so I'm going to use x equals and y equals. You could do it other ways, I suppose. There's no correct way to do it, but you really just want to do whichever is easiest, and here the easiest is using x and y equals from these equations. So we're just going to substitute r sine theta for y here on the left. R sine theta equals 3 over r cosine theta. Okay, however, perhaps you would want to simplify this. I'm not sure, but I'll do it anyway. So here what we're going to do is we're going to multiply both sides by r cosine theta. We're trying to get r on both sides, or r equals. So we're going to multiply both sides by r. This leaves us with r squared sine theta cosine theta equals 3 over r cosine theta times r cosine theta. And now, if you look at this, you can see that this is going to cancel out because, we just simply have this fraction here. We're going to cancel this. So I can rewrite this as r squared sine theta cosine theta equals 3. Now, I assume that the person asking this question, this is some sort of problem that was made up, because normally you might not be able to simplify this, but here we can make it a little simpler. So if you remember our double angle identity, we have the trig identity lowercase s, sine 2u equals 2 sine u cosine u. And so here, to sort of get this over here, I'm going to multiply both sides by 2, so 2r squared sine theta cosine theta equals 6, so we're multiplying by 2. Just rewrite that. Okay. And then we're simply going to get r squared times sine 2 theta. Again, we're solving for r, so r squared equals 6 over sine 2 theta, and r equals plus or minus, again, don't forget the plus or minus sign here when we're taking the square root 6 over sine 2 theta. So here's our polar equation. Again, here there's no right way to do this. You could have multiplied both sides by y and added x squared to use this. But it's simply a matter of which is the most convenient. So here, substituting these for x and y was the most convenient. And then here you didn't have to simplify this in this problem using this trig identity, but it's something you'll have to do occasionally, so I figured I'd do it just to show you that you would recognize that as an identity. And then here, that's just like that. Okay, so I hope that answered your question. If you have any more questions, be sure to ask away in the comments. Okay, so in the meantime, I can talk about something else. So let me just get some more room here. We can talk about inverse functions. Sort of went over this already, but I figure we can just go over it again. Okay. So if we have function, I'll just write f of x equals x squared plus 5x to the fourth sine x. Find its inverse. So here, if you remember the 1-to-1 rule, I'll write this in another color. Okay, I have another question, so I'll get to this in a second. The question is, convert 3 secant theta to Cartesian. Okay, so let me write that out. Convert r equals 3 secant theta to Cartesian. Okay, so if we remember our polar master equations here, r squared equals x squared plus y squared, x equals r cosine theta, y equals r sine theta, and tan theta equals y over x. We essentially need to get one of these in our equation, and then we can substitute for x and y. So here, I'm going to write this out as r equals 3 over cosine theta. We remember that secant equals 1 over cosine. So here, if I'm going back up to my equations, I see that in x equals, I have r cosine theta. And right here, I have a cosine, so I'm going to use that equation here. So to get r cosine theta, I need to multiply both sides by 1 over r. So 1 over r times r equals 3 over r cosine theta. Okay, and so simplifying this, we get 1 equals 3 over r cosine theta. And this right here, we can substitute, knowing the equation x equals r cosine theta. So if I just simplify here, 1/3 equals 1 over x. I'm just simply taking this 3 and dividing it. And here I can cross multiply and just get the equation x equals 3. Okay, so hope that answers your question. If you have any others, be sure to ask away. Otherwise, I can keep going. So again, this is our answer. Okay. So going back to inverse functions, I can talk about the 1-to-1 rule. A function has an inverse only if it is 1-to-1. Now, essentially, this means that a function is only going to have an inverse if each y value corresponds to only one x value. So again, when we take an inverse, we're switching x and y. And if a function has two x values for one y value, it's going to have two y values for one x value. And if you remember anything about functions, this would mean that this equation is not a function if it has two y values for one x value. So that's where this one-to-one rule comes from. And so normally we can do the horizontal line test on the graph, draw horizontal lines, see if it has an inverse. But here it's not so easy. This isn't really something that you're going to graph by hand. And if you don't have a calculator, this might be a little tricky to solve. So let's try it. So again, we're swapping x and y. X equals y squared plus 5y to the fourth sine y. And here it's not really simple to solve this for y. If I start factoring out y's, I'm going to end up with something sort of strange, and this is never going to be converted to y equals. So let's do it another way. Let's factor. So x equals y squared plus times 1 plus 5y squared sine of y. And okay, so here we can simply see that this function is not going to be one-to-one. This sort of, you can't split this up, but if I did, which wouldn't be correct, but I'll do it anyway for the sake of the argument. If I split this up, I can immediately see this one is not one-to-one. And again, this one is also not one-to-one. As you all know, x equals y squared. I'm sorry, not one-to-one is not a function. This here is not a function. Neither is this. So when we multiply them together, we're not going to be getting a function. So here, we can just simply say no inverse. Okay, so that was sort of a hard conceptual problem. Probably you would never be asked to do something like that on the AP test, but sort of useful to know the concept behind what you're doing rather than just sort of mindlessly plugging in numbers. Alright, so if we have any questions, you know, anytime that I'm sort of working something random out, you can ask in the comments. Otherwise, I'll continue to just do sort of random stuff. Okay, so I can go over more limits now. If you guys remember, the limit okay, so the question is what kind of questions are fair game for the free response portion of the AP exam? So for that question, there's not really a straight answer. You're going to see a lot of stuff on integrals and derivatives, which I'll talk about later. And it's important in those that you say the right stuff. Again, I'll talk about that a little later in the series. But in general, they're not going to ask you, you know, explain the squeeze theorem or explain to me conceptually what a limit is. You're almost always going to be working out problems. That being said, if that answer sort of confuses you, or you want like a more detailed answer, you should go to our website, LearnAP.com, and under that you can click on the Resources tab. And then you're going to want to select AP Calculus. You can also select AP Chemistry if that's what you're looking for. So again, you're going to click on the Resources tab, and that's going to bring you to an article where we basically lay out a bunch of resource recommendations. And on there we have practice, we have a bunch of links to practice AP tests online. As I mentioned in the article, I wouldn't really look at those right now. But if you're really looking to sort of figure out what sort of questions are fair game, you should definitely go to our website, click on the Resources tab, and then check out the links we have there, and that should give you a better idea of what sort of questions you can expect on the AP test. So a good question, definitely something you would want to worry about. But again, you know, probably later in the year you should start worrying about that kind of stuff. Right now, I would just make sure that you have a firm grasp on what we talk about in the videos. No problem. Okay, so I've been talking a little bit about limits in our videos, and if we remember, we have several indeterminate forms: 0 over 0, infinity over infinity, we have infinity minus infinity, we have 0 plus or minus infinity, 1 to the infinity, 0 to the 0, infinity to the 0, and okay, and that's it. So these are what we call our indeterminate forms. So basically what this means, indeterminate means that we don't actually know the value. So if I had, like, say 1 over 0, I knew that this was probably going to infinity or maybe negative infinity. However, or like say I got like 8. This is going to 8. But if you do direct substitution and you get an indeterminate form, you can't tell the answer from that indeterminate form, so you have to do more work. So if you remember early on in the live stream, we did this limit question right here, which was erased a little bit, but okay. So here, when we first did direct substitution, we got an indeterminate, 0 over 0. So all that means is that we needed to do more work, which, you know, we did and eventually got the answer. So that's just an important note about indeterminate, you know, sort of why they are what they are and what to do if you see one. So in our videos this week, we've been talking a lot about limits, and next week we're going to be uploading a video about ways to determine limits without L'Hopital's rule. And L'Hopital's rule is very useful if if you can do it. But a lot of times, you know, there are certain times when you can and can't do L'Hopital's rule. So you need to know how to solve it without L'Hopital's rule. So let's sort of look at some sort of random limits that will illustrate some basic guidelines on how to evaluate. We'll just do some practice problems. Limit as x goes to 3, x minus, oops, I'm sorry, x squared minus 9 over x squared plus 9. Okay, so for this one, again, we always plug in, we always do direct substitution first, and we get 0 over 0. Now, an important note about 0 over 0 is that this is also infinity over infinity. This is because I could, so let's say I have a fraction 3 over 2. I'm sorry, that's a little confusing. So let's say I have a fraction 3 over 2. I can also write this as 1 over 3 over 1 over 2. So similarly, for 0 over 0, I could write, say, 1 over 0 over 1 over 0, or infinity over infinity. So these basically mean the same thing. But okay, we have an indeterminate form. Let's try to fix it. Or let's try to solve. So the method that jumps out at me first is to factor this. Factor the top, and then factor the bottom. Now it looks like this is just an easy problem. I can cancel everything and this comes out to 1. But not so fast, because this x squared plus 9 means that this can't be factored by the difference of two squares. Difference of two squares is literally the difference of two numbers that are squared, or one number squared subtracting another number that's squared. Here we have that, but we have an addition sign, so it can't be factored that way. So we're going to have to do something else. So let's try to conjugate it. Okay, so limit as x goes to 3. And now again, we always conjugate the thing with the minus sign. So here, x minus 9, we'll use that as our conjugate. So again, our conjugate is our first term, and then the opposite of our second term, which here is negative 9. The opposite being 9. Alright, and let's simplify that. X to the 4th minus 81. And then here, if I do this, I'm going to get simply x squared plus 9 squared. Now, if we look at our thing, conjugating didn't really help us here. Again, I just still have something on the bottom that I can't factor and something at the top that's not going to cancel. So, okay, I can try conjugating a different way then. So let's conjugate by the bottom here. So x squared minus 9. So if I write this one out, I'm again going to get x squared minus 9 squared all over x squared minus x squared minus 81. Okay, this is a little more promising. We'll see what we can do here. Here, this isn't really going to help us again. I can't factor this one in a meaningful way to cancel out terms, so it's clear here that conjugating is not the right way. So what we should do instead is look at seeing if we can pull terms out and evaluate this limit separately. So if you remember anything about fractions, you would know that 1 plus 2, like let's say 1 plus 2 over 3, is equal to 1/3 plus a half. I can sort of divide this term like so and rewrite it like that. Let's try that for this limit. So I'm going to take x squared plus 9 and divide it by x squared. So x squared over x squared plus 9. And then here we have minus 9. So I'm just simply going to write that out. And okay, now it looks like we're getting somewhere. So let's plug this one in. 3, so we have 3 here, so we have 3 squared all over 3 squared plus 9 minus 9 over 3 squared plus 9. And this is going to get us to 0. So that's a very simple way of doing this. Actually, I'll just write this out real quick. 9 over 3 squared is 9. 9 plus 9 is 18. 9 over 18 minus 9. And then again, 3 squared plus 9 is 18. Here we get 0. And so that's one way of doing this limit. An even easier way than the way I did, which again was long and I wasn't really sure the right way to do it right off the bat. A good way to do it is to just know end behavior. And I talked about this a little bit in I believe the fourth video. So if you remember this, we have a horizontal asymptote. I'm sorry, don't forget about that. End behavior would only work if we were going to infinity. Here we're going to 3, so it's not really obvious that this one's limit was 0. But okay. So if you have any other questions, again, be sure to ask in the comments. Otherwise, I can continue to just sort of do random limits. Okay, so I'll do another limit problem here. You know, sort of our videos this week were all about limits, and we're going to be talking about them all the way through next week. So I'll just continue to do random limit problems to make sure that you guys sort of understand this stuff and how you would evaluate a limit. Alright, so let's try this one. Limit as x goes to 0 of absolute value of x over x. Alright, now this one is much more difficult. So if I plug this in, I get 0 over 0. But here it's not really clear how I should simplify this. Okay, we have a quick question, so I will come back to that one. The question is, what is the amplitude of the function y equals 3 times the quantity of cosine 3x, and also asking for the period. So I'll write that out. Okay, so for this one, we simply have to know the basic format for how to determine period and amplitude in a trig equation. So if we have y equals k sine x, or y equals k cosine x, the amplitude is the absolute value of k. So again, absolute value of k, let me write that out a little more clearly, is the amplitude. So here, our k, or essentially what we're multiplying cosine or sine by, is simply 3. So for our amplitude, I'll put this in a box here. Okay, so our amplitude, say absolute value of 3, or just 3. Now our period is a little bit more tricky, but it's actually not too tricky. So y equals sine kx, kx equals 2 pi, x equals 2 pi over k, where x is our period. Absolute value of x. And note that this does not apply to tan or arctan. So if we have tangent or arctangent, it's going to follow the same thing except kx equals pi. And then so our period would be the absolute value of pi over k. This is because cosine x has a period of 2 pi, as does sine, cosecant, and secant, while tangent and cotangent both have a period of pi, so that just changes our equation. So here we have y equals 3 cosine 3x. Now we know that kx equals 2 pi. Here's our k. And simply speaking, 2 pi, when solving for amplitude, is equal to whatever's inside of the cosine parentheses. So 2 pi equals 3x. Again, absolute value of x is our period, so I'll solve and I get that our period is the absolute value of 2 pi thirds, or just 2 pi over 3. So good question. If you have any more, if you had a question about the solution, be sure to ask, but otherwise I can move on to another problem. Okay, so I'll actually just do this below. Okay. Now, let's think about how we would solve absolute value of x over x. So again, if you forgot, our question is the limit as x goes to 0 of absolute value of x over x. Okay. So, and then again, plugging in, we get 0 over 0. So let's think about what this means. Absolute value of x over x. So anytime that we have absolute value of x, I can basically write this as a piecewise function. So if I have f of x equals absolute value of x, I can write g of x as, say, if x is greater than or equal to 0, and if x is less than 0. If it's greater than or equal to 0, it's just x. And if x is less than 0, it's negative x. If you're confused, either of these are correct. You just simply need 1, because 0 and negative 0 are the same thing for the purposes of AP Calculus. So here I can say that f of x is equal to g of x. I'll leave that up actually. So let's simply think about this one conceptually. We know that we're sort of getting different values as we approach from different sides. So if I evaluate this limit from both sides, I might be able to get a more clear answer. So here, limit as x approaches 0 from the right. Let's plug in numbers that are very, very small but positive, so right from 0. So here if I say 0.0001 all over 0.0001, I just simply get 1. I'm just dividing by myself. Now here, if I'm approaching from the left, we're getting numbers that are very, very close to 0 but negative, because we're approaching 0 from the left-hand side. So negative 0.0001 absolute value all over negative 0.0001. Alright, so if I evaluate this, the top is going to become positive because I'm taking the absolute value, but the bottom is going to stay negative. So here I get negative 1. Now we can see that I'm getting two different things for the limit from both sides. This means that our limit does not exist. And I'll write out the answer in another color. So again, to say that a limit doesn't exist, let's first just write out the limit I'll just write out lim as x goes to 0 of absolute value of x over x does not exist because limit as x goes to 0 from the right is not equal to, we should write out what we're dealing with here, is not equal to limit as x goes to 0 from the left. And this is how you would want to write it out on the AP test. So we're saying that our limit doesn't exist because the values approached from each side are not equal. This would be something to say on like a free response, but multiple choice. Obviously, if you get does not exist, fill in the bubble that says does not exist to move on. But this would be something that you'd want to write out for the free response portion. And that would only be if you were sort of asked to explain. If they just said to evaluate the limit, you can just write out does not exist. But a lot of times you might be asked, explain why this limit does not exist, or explain why it's not continuous. So that's sort of like a keyword, explain. So you should definitely know how to do that. Alright, so if I have any more questions, I'll answer them, but otherwise I'll move on. Let me draw out my coordinate axes. Okay. So let's say we have some function. This is our function f of x. So let's talk about f of x. So here, at which points might we get a limit? I'm sorry, I'll write this out. Okay. At which points might the limit value I'll just write this out mathematically. Limit as x goes to c of f of x not equal f of x. I'm sorry, f of c. Okay, so which points on the graph might this be true? Well, firstly, if I'm just simply taking the limit at each point, it's important to consider whether what I'm getting is going to be the same as the function value. That's essentially what this is asking. At what points is the limit different from the function? And so, in general, those are going to be the same, but if we have a strange graph like this, the really strange points stand out. So here, here, here are our candidates. Well, if we take the limit here, at this point, we'll call this A, we'll call this B, we'll call this C. Alright, so if I take the limit at A, I'm going to get some sort of value. I didn't indicate what it was, but, I'm going to sort of approach something. Let me just draw this. Okay, now we'll get a value. Otherwise, that might not have been true. Okay. So here we're going to get something because even though there's a hole in the graph, we're approaching the same value from both sides. So, but if we take the value of the function at A, we're not going to get a value because there's a hole at A. So we can say at point A, we'll say the limit as x goes to A of f of x exists, but f of A does not. Okay, so at one point we can say the limit at point A exists, but f of A does not. So at A, our limit is different from our function. If we look at point B, you can notice pretty quickly that my limit is going to give me a value of whatever y value this is. But the function is actually defined up here. So I can also say that at point B, limit as x goes to B of f of x is not equal to f of b. So here's f of b. This is where the function is defined at b. And here is the limit as x approaches b of our function. Now if we look at point C, I can see that my limit's not going to exist. We have a jump discontinuity. We're approaching this point from the right and this point from the left, so our limit doesn't exist. However, the function is defined right here. So this is f of c. So we can also say that at point C, limit as x goes to c of f of x does not exist, but f of c is defined. So at all three of these points, a, b, and c, our function is not equaling our limit for separate reasons. Alright, so I will answer any more questions if you guys have any more. So I'll give that a few seconds. We only have a few minutes before the Chem live stream starts. So if you're taking AP Chemistry, be sure to stick around for that. But otherwise, if anybody has any more questions, just ask away. I'll wait like 30 seconds or so just to see. Okay, so it doesn't seem like you guys have any more questions. Like I mentioned, immediately following this video, we're going to be doing the AP Chemistry live stream. So if you guys are in AP Chemistry, stick around for that, and I'll be answering your chem questions. If you like this live stream, if you found it helpful, be sure to like and subscribe. We do these every week. Every Sunday from 4 to 5 p.m. Eastern are our calc live streams, and then every Sunday 5 to 6 are our chem live streams. So subscribe for that, like the video if you liked it. Other than that, I'll see you guys in like 2 minutes for the chem live stream.